Hello students, today we are going to cover the topic high frequency response of CE amplifier. We have already completed low frequency response of CE amplifier and Miller's theorem in the class. Miller's theorem is required as a prerequisite for high frequency response of CE amplifier. So basically you all know during low frequency response we have to consider during low frequency response we have to consider the external capacitances like C1, C2 and CE. For high frequency response we have to consider the parasitic capacitances or internal capacitances of the transistor. So this is high frequency equivalent circuit of CE amplifier. You can see as we do in AC analysis, mid frequency analysis, VCC is grounded. Here also after grounding VCC we got this equivalent circuit and we have drawn two capacitances CBC and CBE. CBC and CBE. The other things you know, this is the output capacitance CL, RL. The circuit you know very well. So here for high frequency response we are not going to consider C1, C2 and CE as we do in AC analysis for mid frequency response. We only consider C1, C2 and CE for low frequency response of amplifier. So here we are not considering this. How we are not considering? We are considering these capacitances as short circuit. So after short circuiting these capacitances and grounding VCC, we got this equivalent circuit, high frequency equivalent circuit for CE amplifier. So now CBC is the feedback capacitance from base to collector. CBE is the capacitance between base to emitter. Internal capacitance or parasitic capacitances of actually they are capacitive effect. They are not the elements or capacitive elements connected in the circuit. So these are basically the capacitive effect. So now you know Miller's theorem. This is CBC. CBC is the feedback capacitance between the input and the output circuit. So this can be splitted into CMI and CMO at the input circuit and the output circuit by using Miller's theorem. We have already done Miller's theorem in the class. You know the derivation, you know the expressions for CMI input capacitance and output capacitance, Miller's input capacitance and Miller's output capacitance. We are going to use it in this particular topic as well. So now again we have redrawn the circuit. Again this CBC is splitted into CMI, Miller's input capacitance, and CMO, Miller's output capacitance. So we have this circuit. Then we have redrawn the circuit by replacing the symbol of transistor by its equivalent circuit, beta RE and beta IB. This also you know very well. So what we have in the circuit: input resistance RS, source resistance RS, R1, R2 are in parallel, CMI and CBE are in parallel. So these can be added. The equivalent capacitance will be addition of these two capacitances in parallel will be added to get the equivalent capacitance CMI plus CBE. Beta RE, beta IB, RC parallel RL, two resistances in parallel, CMO and CL are in parallel. So the equivalent capacitance will be CMO plus CL. So final equivalent circuit, high frequency equivalent circuit of CE amplifier. Again we have to calculate high frequency. For calculating high frequency we have to consider for input circuit and output circuit as well. So for input circuit, FHI, high frequency for input circuit, 1 upon 2 pi RTHI into CI. What is CI? CI is equals to CMI plus CBE. Very easy. CI is equals to CMI plus CBE. this CMI will be given by CBC into 1 minus A, where A is the gain. So this already we have done in Miller's effect topic plus CBE. CMI is given by CBC into 1 minus A plus CBE, where A is gain of the amplifier. RTHI will be given by R1 parallel to R2 parallel to RS parallel to beta RE. This is what we got. So in this way we are going to calculate input frequency. Then we have to calculate for output frequency. So output frequency is given by FHO is equals to 1 upon 2 pi RTHO into CO, where CO will be given by CMO plus CL, Miller's output capacitance plus CL, which is equal to 1 minus 1 upon A CBC plus CL. Again this formula for output capacitance, Miller's output capacitance is already derived. You can refer the class notes. So this is again gain 1 minus 1 upon A CBC plus CL. RTHO is equals to RL plus RC plus RO, small RO. If it is given in the numerical, then you have to consider it, which is the internal resistance, internal output resistance of the transistor, which will be in parallel with this. So this will be RC parallel RL is RTHO and CMO plus CL is CO. So this we got. In this way we will be getting the value of output frequency. Now which one we have to consider? High frequency we have to calculate. So high frequency will be the minimum of these two, minimum value from this of these two. Got it? Okay. If